All right. Hello, class. Um, Hope you guys are doing well. Hey, those of you who are watching, um, try to reach out to the people who aren't watching because this class has the lowest viewership, I think. Um, even factoring in the fact that this is my smallest class, it still has a lot of people aren't filling out the homework. A lot of people in this class aren't doing the homework. So, and they're not watching the lessons either. So, if you know someone who is in our class and is not participating and you talk with them, say, hey, Mr. P's wondering where you are. Um, so, hey, Christian. Hey, Spicy Pepper. Hey, Diego. Hey, Akshay. Hey, Galen. So, what we're going to do for the next few weeks is review for the IB exam. That I know you guys aren't taking it, but I'm still going to give you a final exam that's an IB exam. It's a final exam. I'm going to let you work in groups of 4. But I think that doing a final exam is a good way to just kind of take all that knowledge and put it together and solidify it. So I actually like taking tests when I was, in school because it forced me to take everything and put it all together and memorize it once and for all. And, if you spend the time to do that, then it's like you have it, okay? You don't see me looking at notes when I'm lecturing you guys because it's all in here. And it's all in here from when I studied for my tests. So, it's worthwhile to, put it all together. So that's what we're going to do. And so we're going to practice some IB exams. And let me show you where to find the mother lode of IB exams. All right? I'm going to show you the mother lode. Let's see. Where's my window? I have too many windows open. Oh, here it is. All right. So the website you want to go to is ibdocuments.com. Let's check it out. All right. I'm like 90% sure, actually more like 95% sure that this website is not this is not a website that is run by IB. It's probably run by Redditors. So, I've seen a lot of these sites over the years that have a bunch of past papers and they disappear because I think that IB goes after them. And then a new website with all the past papers pops up. So this is the current website with all the past papers. All right. So ibdocuments.com. And then you have IB examination papers organized by subject. So we can click on that. Oh, whoops. Let me go back. So IB examination papers organized by subject. Group 4 is the sciences. So click that. And you can see all the subjects. Here's Physics SL. And it has every single IB exam ever given. Well, maybe not every single one, but a whole lot of them. Since before you were born, it has the 1999 examination session. Okay? All the way up to November. And so let's click on May 2019 because that's what we're going to do. And we're going to do May 2019, time zone 1, paper 1. So that would be this one right here. I don't know if you can see my highlighting, but that's it. Okay. So that's the one we're going to do. You can see right below it is the mark scheme, so it has the answers. So that's a good resource for you to take a look at. Okay, let me check for questions. Thank you for the compliments on my hat. This is a really cool hat. One of the things I like about it is it's Velcro. So I have another one that says Pettibone, and so you can kind of like switch out what's on the front of the hat. It's pretty cool. Okay. So we are going to do 2019 Time Zone 1, Paper 1, and we are going to do the odd questions in that. Okay? Today, for your practice, you're going to do 2019 Time Zone 1, Paper 2. You're going to do the even questions. Okay? So, I have it right here. So IB gives its exams in 2 different time zones. Okay, time zone 1 is Europe. Time zone 2 is the Americas. So there's 2 time zones each year. So there's 2 exams for every year, and then there's a November exam, which is the same exam throughout the world because not many people take the exam in November. So we're going to do the odds today. One of the things you'll notice about the IB exam is that the first question is always about data analysis. Okay? The first question in paper 1 is always about data analysis. Okay? So what we have here, let's see what it says. It says I might need to make that a little bit smaller. There we go. A student wants to determine the angular speed of a rotating object. The period is t. The period t is 0.5 plus or minus 5%. That many seconds. The angular speed is 2 pi over t. What is the percent uncertainty in the angular speed? So this is a propagation of error question. And one of the things that I taught you is that if things are multiplied or divided, the percent uncertainties add. So the percent uncertainty in angular speed is going to be the percent uncertainty in 2 pi plus the percent uncertainty in period. Well, the percent uncertainty in 2 pi is 0, and the percent uncertainty in period is 5%. Okay? So what's 0 plus 5%? It's 5%. So the answer is C for question 1. I'm going to annotate it. I'm going to go. How do I strike through? Maybe I can. Well, yeah, C. All right. Let me see if anyone has any questions. No questions. So we're doing the odds. So you guys are going to do the evens. The skydiver falling at terminal speed when he or she opens her parachute. What are the direction of her velocity vector and the direction of her acceleration vector before she reaches the new terminal velocity? If you open your parachute, opening your parachute doesn't make you start going upward into the sky. So the direction of the velocity vector is going to be downwards no matter what, because you just continue to fall. But your fall is slowed. So your velocity goes from being downward to a little bit less downward. So that means that the acceleration is against the velocity, so your acceleration is going to be upward. So the answer is C. Okay. Make sure to throw your questions in the live chat if you have them. When are the even questions due? Next week. Thank you for your question. Hey, Galen, tell me how that Kafka book was. I've been thinking about it. All right. Number 5, a ball is thrown upwards at an angle to the horizontal. So this immediately makes me think of projectile motion. Air resistance is negligible. Which statement about the motion of the ball is correct? So if something is in projectile motion, the only thing accelerating it is gravity, which is pointed downwards the whole time, okay? So the acceleration of the ball does not change during its flight. The velocity of the ball changes during its flight. That's definitely true because as the projectile goes up into the air, it's going to slow down because it loses or it gains gravitational potential energy, so it loses kinetic. So I would say B is true. The acceleration of the ball is 0 at the highest point. That's not true because otherwise it would stay at the highest point. The velocity of the ball is 0 at the highest point. The velocity of the ball is 0 at the highest point only if you throw it straight up into the air. But something can still be moving horizontally at the highest point. So for this one, I would say that the answer is B. All right, switching. The other thing I want you to notice about these questions is they go from they sort of progress through the topics in the same order that we progress through them in class. Number 7. 2 blocks of mass m and 2m are traveling directly towards each other. Both are moving at the same constant speed v. The blocks collide and stick together. What is the total momentum before and after? So this is a conservation of momentum problem. Momentum is conserved, so you have to have the same momentum before as you do after. So that means that it's got to be either A or D. Now, what is the initial momentum? You have 2mv going to the right, and you have mv going to the left. So we have 2mv minus mv equals mv. So the momentum before is just mv, so the answer is A. All right. Going to number 9. A block is on the surface of a horizontal rotating disk. The block is at rest relative to the disk. The disk is rotating at a constant angular velocity. Which is the correct arrow to represent the direction of the frictional force acting on the block at the instant shown? The block is undergoing circular motion. And as we know, if you're going in circular motion, you need a centripetal force to remain in the circle. And the centripetal force points towards the center. So, towards the center of the circle would be in the direction of C. So frictional force is the centripetal force, which points towards the center of the circle in the direction of C. Number 11. So we're progressing through the topics. An insulated tube is filled with a large number of lead spheres. The tube is inverted s times so that the spheres completely fall through an average distance L each time. The temperature of the spheres is measured before and after the inversions, and the resultant change is delta T. What is the specific heat capacity of lead? All right. So I might have to work out some equations for this one. So we have Let me try this. Need to add some text here. All right. Q equals mc delta t. All right. Let's see if I can do a J. Ooh, nice. Alt J is the symbol for delta, if you wanted to know. So the heat added is equal to the gravitational potential energy that is released every time you flip this over. So that means that Q is going to be mgl. So that's the amount of gravitational potential energy that's released each time. And you flip it S times. So that's the amount of heat that's added to the lead spheres. And that's equal to mc delta T. Okay. You can see that the mass of the spheres cancels out. And we get C equals SGL over delta T. Which the answer is B. All right. Number 13. A storage tank of fixed volume V contains N molecules of ideal gas at temperature T. The pressure is blah. N over 4 molecules are removed, and the temperature is changed to 2T. What is the new pressure of the gas? All right. Let's take care of this problem. So I can write the ideal gas law. The ideal gas law says that P equals nRT over V. The volume of the gas is fixed. But we can see that N went to N over 4. Okay. So that's going to reduce the pressure, N went to 3N over 4 because it says N over 4 molecules were removed. So that means that there's 3/4 remaining. So the pressure went to 75% when we removed those molecules. And then the pressure, we doubled the temperature, which is going to double the pressure. So we got to double 75%, which is 150%. 150% of 20 is 30. So I think the answer would be C. All right. Correct me if I'm wrong. Number 15. Which of the following shows the variation with time of the kinetic energy of an object undergoing simple harmonic motion of period T? The kinetic energy cannot be negative. So the answer has to be C or D. All right? The smallest kinetic energy can be a 0. Now, when something is undergoing simple harmonic motion, it is going back and forth like this. So we can see that every period, it swings through the center twice. It kind of goes, swings through once, swings through twice. Each time it swings through the middle, the kinetic energy is big. So for every period, we have 2 peaks of the kinetic energy. So you can see that option D has 2 peaks in one period. So the answer was D. All right. Which of these waves, 17 is a gimme. Which of these waves cannot be polarized? Only transverse waves can be polarized. Longitudinal waves can't be polarized. So options A, C, and D are all parts of the electromagnetic spectrum. They're all light waves, which are transverse. B is ultrasound, which is a longitudinal wave, which cannot be polarized, so the answer would be B. Number 19. Oh my gosh, what is this? In science, models are used extensively used to study real-life situations. A person X on the beach wants to reach person Y in the sea in the shortest possible time. The speed of the person X on land is different from the speed of the person X in the water. Which physical phenomenon will best model the path with the least amount of time? Wow, this is a stupid question, but I will answer it anyways. You want to think about it. Remember how electromagnetic waves, when they enter a new medium, they have different speeds. Okay. So it's like N1 and N2. So you're talking about like N1 is the beach, N2 is the sea, and the person is going to, if you want to reach person Y the fastest, you're going to want to basically run along the beach until you're directly in front of the person, so you spend as little time as possible in the ocean. So the light is going to, so basically the person is going to change their path direction once they hit the water. And that's exactly like refraction. Refraction is where light bends as it enters a new medium. So the answer to this would be D. I think that's a really silly question, but it is what it is. Two cells, each of electromotive force 9 volts and internal resistance 3 ohms, are connected in series. A 12 ohm resistor is connected in series to the cells. What is the current in the resistor? Let me check and see if I have any questions. So basically we're going to use Ohm's law. Now if we have two cells of EMF 9 volts and they're in series, that's going to be a total EMF of 18 volts. If we put two batteries in series, their internal resistances are going to combine. So the internal resistance will be 3 ohms, okay? 6 ohms. And then that is in series with 12 ohms. So 6 ohms in series with 12 ohms is going to be 18 ohms. So our total resistance is 18, our total voltage is 18. That means our current is 1 amp. So the answer would be C. Okay. Number 23, this has to do with the magnetic force. A beam of negative ions is flows in the plane of the page through a magnetic field. In which direction will the negative ions be deflected? The magnetic field is going to be pointing downward. It's going to be pointing downward. That's the direction of the magnetic field. So then what we have to do is we have to use the left-hand rule. It's a negative charge. So my velocity is to the right. My magnetic field is downward. And so the force is out of the page. Using the left-hand rule because it's a negative charge. So that would be, the correct answer would be A. All right. Number 25. Satellite X orbits a planet with orbital radius R. Satellite Y orbits the same planet with orbital radius 2r. What is the satellites X and Y have the same mass? What is the ratio of the centripetal acceleration of X to the centripetal acceleration of Y? The force causing the centripetal acceleration is gravity. So I would say that, first of all, I would say A equals F over M. And the force is the gravitational force. So you would have G big M little m over R squared over M. Okay. Which is just, so the centripetal acceleration is Gm over R squared, where M is the mass of the planet. So we can see that if we double the radius, we actually get 1/4 the centripetal acceleration. So X is actually going to have 4 times the centripetal acceleration of Y, so the answer would be D. Okay. The rest mass of a helium isotope is M. Which of the expressions gives the binding energy per nucleon for helium, the helium isotope? So we know that binding energy is mass of the separated nucleus minus mass of the formed nucleus. Okay, so that means that the mass of the separated nucleus is going to be 2 protons and 1 neutron. And the mass of the formed nucleus is M. So that's the binding energy. Now the binding energy per nucleon is going to be the binding energy divided by the number of nucleons, which is 3. So it looks like the correct answer would be B. I have any questions? Christian asked, what was the difference between diffraction and refraction? So refraction is when a wave bends as it enters a new medium. Diffraction is when a wave stays in the same medium, but it bends around an object. So if you put an obstacle in the way of a wave, it'll kind of bend around it. That's diffraction. All right, last question for today, number 29. A beaker containing water at room temperature is heated on a hot plate. What will be the initial rate of change of temperature? So notice that the answers are in kelvins per second. That's temperature per time. So we're going to want to use Q equals mc delta T. And then we're going to take both sides and divide it by time. What you'll notice is that this is basically the sous vide cooking problem from this is the sous vide cooking problem from your exam a couple weeks ago, and it's asking for a change in temperature over time. So the Q over T is the power that's input to the water. So that would be 400. The mass of the water is 1 kilogram. The specific heat capacity is 4,200. Okay, and then times delta T over time. So that says that delta T over time is equal to approximately 0.1 Kelvin per second. So that would be C. All right, so that's my lesson. You guys are going to do the odd or the even questions. One of the things that I observed about that multiple choice, that was a really easy multiple choice. I don't know if you guys felt that was the questions that I did were piece of cake, I thought. So hopefully, at least with me explaining them, you felt that they were a piece of cake as well. You can see that it is incredibly useful to have the definitions in your head. Okay? It's really hard to problem solve if you don't have the definitions in your head, if you don't have the formulas in your head, because you don't know what you don't know if you don't have it in your head. All right. So I hope you guys have a really good afternoon. I hope maybe I'll talk to some of you on Discord. See you later.